Hello, my name is Josh Obert, and I am a GIS analyst with the ACPF National Hub. In this video, we're going to discuss the Identify Impeded Flow Tool. But first, we will go over some considerations for using a LiDAR-derived DEM. We'll be introducing concepts such as hydroconditioning of DEMs and some pre-processing that you should do on your DEM before conducting any sort of flow modeling across the landscape. When you download your DEM, it's very important to go and look at the metadata to see what, if any, pre-processing has been performed on that DEM. One of the methods that may have been performed on the DEM is called hydroflattening. This process is generally performed by the vendor who is collecting the LiDAR. Hydroflattening is what is done to flatten elevations within water bodies and wide rivers. This is done because LiDAR is not collected over water. The pulse that is sent out is actually absorbed by the water instead of returned back to the sensor like it is over landforms. Since there is no data, the water surface is interpolated using the bank elevation, which creates ridges as shown in the image on the left. These ridges can act as dams, which will impede flow. So in these lakes or water bodies and wide rivers, we flatten them, which smooths the surface. And then also a constant downhill gradient is created, which you can imagine this would be important in things like rivers. A second process that can be done in your DEM is hydroconditioning or hydroenforcement, which is where obstructions to flow are cut through a DEM that allow the water to continually move through. In this example here, we have roadways that would have naturally impeded the flow based on the LiDAR because it is seen as a dam. But now it's been cut through, which allows the water to flow. This is not likely to have been done by the vendor. It's a very detailed and time-consumptive process. However, it's extremely necessary to produce an accurate flow model and therefore an accurate watershed planning model. To give an example as to why hydroconditioning is so important, the top left image shows an example of where a cut line has not been made through this road. You have the flow path, and when you do terrain processing and produce a raster, like flow direction or flow accumulation, when you're above the road, everything's moving along fine. It hits that roadway and is treated as a dam, so that flow begins to back up behind and creates a ponding effect until it reaches such a height that it can spill over that roadway. And when that happens, the flow path no longer is falling into the correct channel. And we get this skating rink effect, shown in the bottom left image. So it's extremely important to make cuts where you know they are and you can see them in your imagery or hillshade, because you want your flow paths to fall within the actual channel and not just spilling all over the place, like you can see in that lower image on the right with the white lines. We want accuracy, so we can suggest good results to our watershed planners. The ACPF has been built to assist you in this process of hydroconditioning, and we have some tools that we've developed that will guide you step by step through this process. There are three tools involved in the hydroconditioning process. The first one is the Identify Impeded Flow Tool, which we will go into more in depth coming up here shortly. The second is Visualize Flow Paths, and the third is the Manual Cutter and Dam Builder. These three will be run iteratively to create an accurately hydroconditioned DEM. It's extremely important that you take your time and are diligent through this process. If you don't take your time or skip steps, you're going to lack an accurate flow network, and in return, you're also going to have inaccurate conservation practice placements down the road. The first step in this iterative process is to identify impeded flows. This tool produces a valuable output showing surface depressions across the landscape. Some of these depressions are going to be real and some are not. In the example shown, depressions are commonly developed behind roadways, meaning that flow will be backed up behind these. In reality, these roadways could actually be bridges or have culverts going underneath them or have ditches that would actually direct the flow under or around them. These areas will need to be edited to allow this flow to move correctly. To run the Identify Impeded Flow tool, we'll come over to our catalog window on the right side of the screen and expand the DEM preparation tool drawer within our ACPF toolbox. Identify Impeded Flow is the third tool listed, and we will double click it to open it. We can see it's very simple with just one input, our unfilled DEM. Since this layer is in the map, we can choose it from the drop-down for unfilled DEM. When chosen, the output then gets populated, and it will be called a depth grid followed by the 12-digit HUG ID. We will then go down to the bottom of the window and click Run. Once the tool has finished running, we can give it some color to help with visualizing these areas of backed up flow. Select our depth grid in the table of contents on the left and click the Symbology tab in the right panel to open the Symbology window. We will change the color to yellow, green, blue continuous scheme. Click the drop down for color scheme. Make sure Show Names, Show All are checked. And we're going to scroll all the way to the bottom. There's yellow, green, blue, continuous. We'll click on it to set the new color scheme. We will then change the statistics setting. Click on the drop down next to statistics and we will be choosing DRA. We can start to see some depressions throughout the landscape. Let's zoom into a particular area by either scrolling on the mouse wheel or with the Explore button selected in the Map toolbar at the top of the screen, holding Select, clicking, holding, and dragging a box. We can start to see where roadways are causing backup of flow. These depressions that have flat sides that line up to these features represent those backups. These, applied with the hillshade and aerial imagery, give a good idea of where you're going to need to be placing cuts. For example, along the large impediment in the center of the screen, I would place a cut from the deepest point all the way across the roadway feature so that it can continue to flow into the stream. This will be shown in more detail during the manual cutter dam builder video. In this video, we discussed some of the considerations to think about before beginning the hydro conditioning process. We also ran the Identify Impeded Flow Tool using our DEM. The Identify Impeded Flow Tool is the first of 3 steps in an iterative process to hydro condition our DEM.